This is problem number 1 for section 2.1. In this problem it says find the average rate of change of the function over the given intervals. They give you a function and they give you intervals from 1 to 3 and then -4 to 4. And remember, these are intervals for the inputs. So this is x values 1 to x value 3. So if we're going to find the average rate of change, the first thing we need to do is we need to figure out what the y values are, because we need 2 coordinates to find the rate of change. And right now we don't have 2 coordinates, we just have 2 input values. So let's start by taking f of 1 and plugging it in. When we plug in f of 1, we end up with 10, 1 cubed plus 10, which will give you 1 cubed is 1 times 10 is 10 plus 10. We end up with 20. And then now we're going to plug in f of 3, and we get 10, 3 cubed plus 10. 3 cubed is 27. So 27 times 10 is 270 plus 10, that's 280. And that tells us that we have coordinates that are 1, 20 and 3, 280. So if we want to find the average rate of change, we start by doing 280, right? So m equals 280 minus 20 over 3 minus 1. This is going to give you 260 over 2, which is 130 for your slope. Now let's do the same thing for -4 and 4. So we get f of -4, which equals 10 to the -4, 10 times -4 to the third power, I should say, plus 10 equals -4 to the third power. So 4 times 4 times 4 is 64. So that's -64, -640. Add it with 10, you get -630. And then do the same thing with f of 4. You get 10, 4 cubed plus 10. Well, that's going to be now just positive 640 plus 10, which is 650. So our coordinates here are -4 and -630. And the other coordinate is 4 and 650. So let's go ahead and find the slope. That's going to be 650 minus -630 over 4 minus -4. When you subtract a negative, that's obviously a positive, so we end up with, let's see, that'd be 1280 over 8. We can reduce that by dividing by 2. And when we divide by 2, we end up with, we end up with 620 or 640 over 4. And when we divide that by 4, we end up with 160 for a slope. So that's how you find the average rate of change. Now, I do want to point out that the average rate of change is like finding a secant slope. That's what we're kind of gearing up for, is finding secants and tangent slopes, and the average rate of change is the secant slope.